Okay, so good afternoon, students. Today we will be studying about water and its treatment. Uh, Let us see what is meant by hard and soft water. So what is meant by hard water? Hard water, we can see that the water sample which does not give or produce lather with soap is nothing but is called as hard water. Whereas soft water is nothing but the water sample which gives or produces lather with soap is called as soft water. So the two kinds of water, we studied this previous class. We had already studied this in our previous class. So soft water is nothing but the water sample which gives lather with soap is called as soft water. Whereas hard water is nothing but the water sample that does not give proper lather with soap is called as hard water. And instead of giving lather, it will give a white precipitate which is called as scum. Okay, that is nothing but hard water. Now let us see. Hardness of water is caused by presence of dissolved salts. Okay, what are the dissolved salts that give that cause presence of dissolved salts that cause hardness in water? Let us see all those things. Okay, the dissolved salts that are responsible for causing hardness in water. See here, we are able to see that calcium chloride. This is calcium chloride. This is nothing but magnesium sulfate. Okay, and this is nothing but sodium stearate. C17H35COONA is nothing but sodium stearate, and sodium stearate is reacting with calcium and magnesium salts, and it is giving respective salts, calcium stearate and magnesium stearate. So these are nothing but the white precipitate that is being formed when we are taking bath with hard water. Okay, this is nothing but the calcium stearate and magnesium stearate that is being produced. Now we are going to the next slide. This is our next slide, which is nothing but hardness of water. We are able to see this hardness of water here. So hardness of different kinds of water. So here, this is nothing but soft water. Soft water is around 0 to 70 ppm or milligrams per liter. Whereas moderate hard water is around 70 to 150 ppm, ppm or milligrams per liter. And 150 300 milligram per liter is nothing but hard water. So this is nothing but hard water, and 300 and above is nothing but very hard water. 300 and above is nothing but very hard water. Okay, these are the kinds of hardness of water we are able to see here. Okay, we just need to remember and understand that soft water is around 0 to 70 ppm, and very hard is around 300 and above ppm. Okay, now let us understand what is meant by temporary and permanent hardness of water. Okay, so temporary hardness. What is meant by temporary hardness? Temporary hardness is caused by dissolved salts of calcium and magnesium bicarbonates. Okay, so temporary hardness is caused because of this calcium and magnesium bicarbonates are there, and these are the salts that are responsible for temporary hardness. Now, temporary hardness can be easily removed by boiling. Okay, how temporary hardness is removed? It can be easily removed by boiling. Here we can see the two equations, calcium bicarbonate and magnesium bicarbonate. These are the two equations. Upon boiling, it is a calcium carbonate. It is being removed. Calcium bicarbonate is being removed as calcium carbonate. Magnesium bicarbonate is being removed as magnesium carbonate. And in the process, water and CO2 is coming out. In the process, water and CO2 is coming out. Very important. It's a temporary hardness. We have to understand what is meant by temporary hardness, and we have to understand what is meant by permanent hardness. So temporary hardness, I told you, it is being caused by calcium and magnesium salts. bicarbonates, mainly bicarbonates of calcium and magnesium salts is temporary hardness. And how temporary hardness is removed? It is removed by boiling. So these are the equations. Now permanent hardness. What is meant by permanent hardness? Permanent hardness is nothing but is due to dissolved chloride, sulfates, nitrates of calcium, magnesium. So permanent hardness is due to dissolved chloride, sulfates, nitrates of calcium and magnesium. That is CaCl2, CaSO4, CaNO3 twice, MgCl2, MgSO4, MgNO3. So these are all the salts that are responsible for permanent hardness. Mainly, we need to remember calcium and magnesium, chlorides and sulfates. Okay, or chlorides and sulfates of calcium and magnesium are the ones that are responsible for permanent hardness. And we know that bicarbonates of calcium and magnesium is responsible for temporary hardness. Uh, the important thing is that the bicarbonates of calcium and magnesium, they can be removed by boiling. So temporary hardness can be removed by boiling, whereas permanent hardness cannot be removed by simple boiling. Okay, permanent hardness can be removed by different chemical methods. Okay, it can be, we'll be studying those. Therefore, iron, aluminium, and manganese also cause hardness in water, but they are rarely found in water. We are able to see here expression of hardness in terms of equivalence of CaCO3. Very important. We are looking here expression of hardness. Okay, in terms of equivalence of CaCO3. Very important. How hardness is expressed in terms of equivalence of CaCO3. Now, hardness of water is measured in terms of CaCO3 equivalence. That is a standard. Calcium carbonate is being used as standard in order to express the hardness of water. Now, the weights of different salts are converted to weights equivalent to that of calcium carbonate. The weights of different salts are converted to weights equivalent to that of calcium carbonate. CaCO3 is highly insoluble in water, and also its molecular weight is equal to 100. And equivalent weight is nothing but 50. That makes the calculations easier. Okay, what is the molecular weight of calcium carbonate? Calcium carbonate molecular weight is 100 and its equivalent weight is 50. So because of this reason because of this reason, the calculations are easier, and that's why we are using calcium carbonate as standard for expressing hardness of water. Moreover, calcium carbonate is the most insoluble salt that is present. That's why we are expressing the things in terms of calcium carbonate equivalence. Now we are able to see here hardness of the hardness causing salt in terms of calcium carbonate is equal to amount of the hardness causing salt into 100 divided by molecular weight of the hardness causing salt. Hardness of the hardness causing salt in terms of calcium carbonate is equal to amount of the hardness causing salt into 100 divided by molecular weight of hardness causing salt. So we are clearly seeing here, we are clearly making out that hardness of the hardness causing salt in terms of calcium carbonate is equal to amount of the hardness causing salt into 100 divided by molecular weight of the hardness causing salt. So we are able to express hardness. Important. Hardness in terms of calcium carbonate equivalence we are expressing. How we are expressing? We have to take the how much amount of hardness causing salt is there. We have to multiply it by 100, and then we have to whole divide it by molecular weight of hardness causing salt. That is how we need to express the hardness of hardness causing salt in terms of calcium carbonate equivalence. Now, ppm and mg per liter. What is meant by ppm and mg per liter? These are the units actually. Ppm and mg per liter. These are the units that are used to express the hardness of water. Now, what is meant by ppm? Ppm is nothing but parts per million. and it is defined as the number of parts of calcium carbonate equivalent hardness per 10 power 6 parts of water. 1 ppm is equal to 1 part of CaCO3 equivalent hardness in 10 power 6 parts of water. Milligrams per liter is defined as the number of milligrams of calcium carbonate equivalent hardness per 1 liter of water, which is nothing but 1 mg per liter is equal to 1 mg of CaCO3 equivalent hardness in 1 liter of water. Okay, so ppm and mg per liter is nothing but the units that are used to express the hardness of water. Now, ppm is an important unit and the most common unit that is used for expressing hardness of water, and it is defined as the number of parts of CaCO3 equivalent hardness per 10 power 6 parts of water. Also, milligrams per liter, which is nothing but number of milligrams of CaCO3 equivalent hardness per 1 liter of water. It is per 1 liter of water. Okay, very simple. Now let us see the relationship between ppm and mg per liter. What is the relationship between ppm and mg per liter? We can see here that 1 liter of water is nothing but 1 kg of water, which is nothing but 1000 grams of water, which is nothing but 1000 to 1000 milligrams of water. 1000 to 1000 is nothing but 10 power 6 milligrams of water. So 1 milligram per liter is equal to 1 mg of CaCO3 equivalent hardness in 10 power 6 parts of water. Okay, 1 milligram of CaCO3 equivalent hardness in 1 liter of water. 1 liter of water is nothing but 10 power 6 milligrams of water. So 1 milligram of CaCO3 equivalent hardness in 10 power 6 milligrams of water is equal to 1 part of CaCO3 equivalent in 10 power 6 parts of water is equal to 1 ppm. Thus, mathematically, ppm and mg per liter units are equal. Very important. Mathematically, ppm and mg per liter units are equal. Okay, mathematically there is no difference, but physically we are expressing, we are telling it as parts per million and milligrams per liter. That's all. Now, Clark's degree is another unit. 1 degree Clark is equal to 1 part of CaCO3 equivalent hardness in 70,000 parts of water. Okay, it is previously it is 10 power 6 parts of water. Now here it is 70,000 parts of water. Okay, 70,000 is nothing but 1 gallon of water. Okay, 70,000 we need to remember. 1 degree French. Now let us go to another unit. What is degree clock? We have seen a number of parts per 70,000 number of equivalent hardness, one part of CaCO3 equivalent hardness in 70,000 parts of water. Now degree French, it is defined as the number of parts of CaCO3 equivalent hardness per 10 power 5 parts of water. Okay, degree French is nothing but number of parts of CaCO3 equivalent hardness per 10 power 5 parts of water. Now 1 degree French is equal to 1 part of CaCO3 equivalent hardness in 10 power 5 parts of water. That is what we had studied. Now here we can see the relationship between various units. Okay, ppm, mg per liter, degree French and degree Clark. Now 1 ppm, we know that it is equal to 1 mg per liter, which is equal to 0.1 degree French. Okay, it is equal to 0.1. 0.1 means whatever 10 power 5, it has been reduced to 0.1 degree French in order to make it equivalent to 1 mg per liter, which is also equivalent to 0.07 degree Clark. Okay. Similarly, 1 ppm, 1 mg per liter is equal to 1 ppm is equal to 0.1 degree French is equal to here only 2 zeros should be there. Okay, just kindly there are only 1 zero here. Okay, not 2 zeros, only 1 zero is there. 0.07 degree Clark, and 1 degree Clark is equal to 1.4 degree French is equal to 14.3 ppm is equal to 14.3 mg per liter. Similarly, 1 degree French is equal to 10 ppm is equal to 10 mg per liter is equal to 0.7 degree Clark. Now we will go to the next slide. We will talk about, we'll discuss about what is meant by potable water. Potable water is nothing but the water that is having the important characteristics of potable drinking water. Okay, so as per the suggestions of World Health Organization, WHO, World Health Organization, and by Indian Council of Medical Research, that's ICMR, the following are the important characteristics of potable water. As per the suggestion given by WHO and ICMR, following are the important characteristics of potable water. Now we can see here, we are able to see here, it should be clear, colorless, and odorless. Potable water should be clear, colorless, and odorless. There should not be any color. There should not be anything that is present in water. It should be very clear. It should be colorless, and it should be odorless. Now it should be how it tastes is important. It should be cool. It should not be very hot. We will not be able to take it. So it should be cool, and it should be pleasant to taste. It should not taste. Taste should be proper. If taste is not proper, we will not be able to take it once again. No, it should be clear, colorless, and odorless, and it should be cool and pleasant to taste. It should be free from harmful bacteria and suspended impurities. That is another important point. We cannot take water that is contaminated with harmful bacteria and suspended impurities, and which results in various kinds of diseases. Now, also important, it should be free from dissolved gases like CO2, H2S, and NH3, etc., and poisonous minerals like lead, arsenic, manganese, and etc. Hardness should be important. Hardness should be less than 500 ppm. Hardness should not be greater than 500 ppm. If it is greater than 500 ppm, then the taste of water will not be proper for drinking purpose. And important thing is chloride content should be less than 250 ppm. Fluoride content should be less than 1.5 ppm. Total dissolved salt should be less than 500 ppm. pH of the potable water should be around 6.5 to 8.5. 6.5 to 8.5. The following are the characteristics of potable water. Very important. We should learn and understand what is potable water and its specifications. Okay. For today, we have discussed various topics. We have discussed various topics. What is hard and soft water? Okay. What is meant by hardness of water? What is the temporary and permanent hardness? And how temporary hardness can be removed by boiling, and how permanent hardness cannot be removed by boiling, and we need to use various other chemical methods in order to remove the permanent hardness. And we have also seen what are the expression of hardness in terms of equivalence of CaCO3. Hardness of water is measured in terms of CaCO3 equivalence. Why we are taking CaCO3 as a reference? Because CaCO3 is the most insoluble salt that is present, and its molecular weight is 100 or equivalent weight is 50. That makes the calculations easier. And how do we need to express hardness of a salt in terms of calcium carbonate equivalence? So we are expressing the hardness causing salt in terms of CaCO3, which is nothing but amount of hardness causing salt into 100 divided by molecular weight of hardness causing salt. Now we can see here that ppm. Ppm is nothing but is defined as number of parts of CaCO3 equivalent hardness per 10 power 6 parts of water. So 1 ppm is nothing but 1 part of CaCO3 equivalent hardness in 10 power 6 parts of water. Now milligram per liter. What is milligram per liter? Defined as number of milligrams of CaCO3 equivalent hardness present per 1 liter of water. Now, relationship between ppm and mg per liter. What is the kind of relationship that is existing between parts per million and mg per liter? We know that 1 liter of water is nothing but 1 kg of water, which is nothing but 1000 grams of water, which is nothing but 1000 to 1000 milligrams of water, which is 10 power 6 milligrams of water. And 1 mg per liter is 1 milligram of CaCO3 equivalent hardness in 10 power 6 milligrams of water, which is equal to 1 part of CaCO3 equivalent in 10 power 6 parts of water is equal to 1 ppm. Thus, mathematically, ppm and mg per liter units are equal. Clark degree is equal to part of CaCO3 equivalent hardness in 70,000 parts of water. Degree French is defined as the number of parts of CaCO3 equivalent hardness per 10 power 5 parts of water. 1 degree French is equal to 1 part of CaCO3 equivalent hardness in 10 power 5 parts of water. Now, what is the relationship between what is the relationship between various units? We can see here that 1 ppm is equal to 1 mg per liter is equal to 0.1 degree French is equal to 0.07 degree Clare. Similarly, 1 mg per liter is equal to 1 ppm is equal to 0.1 degree French is equal to 0.07 degree Clare, not 0.00, it is 0.07 degree Clare. Now, 1 degree Clare is equal to 1.43 degree French is equal to 1.43 ppm is equal to 14.3 mg per liter. Similarly, 1 degree French is equal to 10 ppm is equal to 10 mg per liter is equal to 0.7 degree Clare. Now we have talked about what is meant by potable water. Potable water is nothing but the water, the characteristics or the specifications of the water needed for drinking purposes, and these specifications are given by WHO and by Indian Council of Medical Research. Now, these are the specifications. What are the specifications? It should be clear, and it should be clear, colorless and odorless. It should be clean and pleasant to taste. It should be cool, and it should be free from harmful bacteria and suspended impurities. It should be free from dissolved gases like CO2, H2S, NH3, etc., and poisonous minerals like lead, arsenic, manganese, etc. should not be there. Hardness should only be less than 500 ppm. Fluoride content should be less than 250 ppm. Fluoride content should be less than 1.5 ppm. Total dissolved solid should be less than 500 ppm. pH of the potable water should be 6.5 to 8.5. That is how it is. Okay, we have learned all these things. In our next class, we will see how to obtain potable water by means of municipal water treatment. Okay, thank you.